to our lesson on balancing chemical equations. Today, we'll be working the reaction between calcium carbonate and hydrochloric acid. Let's start with our unbalanced equation. We have calcium carbonate plus hydrochloric acid yielding calcium chloride, carbon dioxide, and water. To balance this equation, we'll follow these steps. First, we'll count the atoms of each element on both sides. Then, we'll adjust the coefficients to balance each element. Finally, we'll verify that our final equation is balanced. Let's start by counting the atoms on each side. On the left side, we have 1 calcium, 1 carbon, 3 oxygen, 1 hydrogen, and 1 chlorine. On the right side, we have 1 calcium, 1 carbon, 4 oxygen, 2 hydrogen, and 2 chlorine. Now, let's adjust the coefficients to balance each element. We'll start with chlorine. We need 2 chlorine atoms on the left to match the right side. So, we'll add a coefficient of 2 to HCl. This also balances hydrogen. Next, we need to balance oxygen. We have 3 on the left and 4 on the right. We can't change the coefficient of CaCO3 without unbalancing calcium. So we'll add a coefficient of 1 to H2O on the right side. Let's verify that our equation is now balanced. Calcium, 1 on each side. Carbon, 1 on each side. Oxygen, 3 on the left CaCO3, and 3 on the right, 2 from CO2, 1 from H2O. Hydrogen, 2 on each side. Chlorine, 2 on each side. And there we have it. We've successfully balanced our chemical equation. The final balanced equation is CaCO3 plus 2 HCl yields CaCl2 plus CO2 plus H2O. Remember, in a balanced equation, the number of atoms of each element must be equal on both sides. Balancing chemical equations is a crucial skill in chemistry. It ensures that mass is conserved in chemical reactions and helps us understand the stoichiometry of reactions. Keep practicing, and you'll master this important technique in no time.